Hey, my name is Milan, and in today's video I'm going to introduce you to Azure Service Bus. It's a fully managed cloud messaging service, and it allows you to implement decoupled asynchronous communication between your components. We're going to cover the fundamentals of Azure Service Bus and also how you can use it from your .NET applications. So let's start from the drawing board to understand what Azure Service Bus is. So the first thing we have is a message that we want to send from our applications. Now, when it comes to what Service Bus offers, we have two distinct components. The first one is a message queue, and the second one is a topic. Let me rename this to make it clear that this is not a pipeline, it's a topic. So how are these two message transports different? Well, let me first explain what a message queue is, and then we're going to compare this to a topic to see what's the difference. With a message queue, your application takes in a message and sends it off to the queue. Now, as soon as some other component takes the message off the other end of the queue and processes it, the message is gone for good. This also means that only one consumer can see and process this message, and this isn't ideal if you want to be able to send this message to multiple consumers. So this is the pain point that topics solve. In Azure Service Bus, this is a slightly different infrastructure component, and it also allows you to send a message, in this case to a topic, but what's different in this case is the topic itself defines what are called subscriptions. So let's say this is subscription 1, and we can have multiple subscriptions per topic. So let's say subscription 2 and subscription 3. You can think of these subscriptions as virtual queues where the topic is going to take in the incoming message and distribute it to all of these subscriptions. So in this case, we can handle the same message for each subscription, allowing us to process this message from multiple different consumer applications. Now, I assume you're already familiar with what messaging offers, so I'm just going to highlight what are some of the distinct features that Azure Service Bus has. So one thing you can do is schedule messages so that they are published at some point in the future. This can be very useful when you want to kick off some process, let's say a week after publishing some message. Service Bus also supports deduplication. This is achieved by providing a message ID when sending the message. Now, you have to be aware that this mainly solves networking issues where there's a slight chance that the same message might be sent multiple times. This is a very rare case, and what you're probably more interested in is consumer-side deduplication, and something like this you would have to implement yourself. It also supports dead lettering, so you can have a dead letter queue where your messages can go if we fail to process them after a certain number of attempts. And another thing that I find interesting is filtering, where you can define a specific filter for each of these subscriptions to a particular topic, and then you can filter out any messages for that subscription that you aren't interested in and only consume the messages that you want. So this is a high-level intro to the Service Bus message topology. We have queues and topics and some interesting messaging features that we can implement with Service Bus. Now let's jump into the Azure portal and let me show you how you can create your Service Bus instance. So I'm in the Azure portal, and here you want to look for Service Bus, and it's going to show up as the top service. So once you go into Service Bus, you want to create your Service Bus namespace. This is like grouping for all of your queues and topics, and you typically want to have one namespace per environment. Let's say a namespace for development, a namespace for staging, and a namespace for production, even though inside of them you're going to have the same topics and queues. So let me choose my resource group. I'll choose YouTube, and then let me define the name for this namespace. So let's call this the Azure Service Bus YouTube demo. I'll choose Germany West Central, which is the region closest to me geographically. And then for the pricing tier, you have options between Basic, which is the cheapest one, Standard, which costs about $10 per month, and Premium, which is recommended if you have some high workloads. Now be aware that the basic pricing tier doesn't have support for topics. So I'm going to choose Standard so that we can test out both of these. And then let me click Next. I won't change anything in the advanced section or the networking section, and I can proceed to review and create. And once this completes, I'm going to click Create, and this will start creating my new resource, which is just an Azure Service Bus namespace. Now, inside of this namespace, we can start creating our queues and topics. So let's wait a couple of moments for this to complete. So our new resource is ready, and I can go into the Service Bus namespace. From here, a couple of things are important. You can see the shared access policies in the settings, and this basically exposes a connection string that you can use from your .NET applications to connect to your Service Bus instance. Now you can see that there are a couple of claims: managing the Service Bus namespace, and then sending messages and listening for messages. So let me create a new one. which can just send and listen to messages. You can even be more granular and define an access policy that can only send messages or listen to messages. So let's call this send and receive, and I'm going to create this access policy, and this is what I'll be using from my applications to connect to my Service Bus instance. Just another reminder, what I'll be doing is copying the primary connection string and then using that from my application to connect to my Service Bus instance. Another thing that's important here is if we scroll down to entities in the sidebar, we can see our queues and topics. So let's start by creating a queue. You can see what options we have available, and I'm going to first give our queue a name. So let's call it orders. Then you can choose a maximum queue size, the maximum delivery count, let's say 5 attempts, the messages time to live, which is how long it's stored in Service Bus before it expires or its dead letter. Then you have a couple of options if you want to implement auto delete on idle queues, message deduplication, dead lettering on message expiration, partitioning sessions, and then forwarding messages to another queue or topic. I may cover these options in some of my future videos. We're going to deal with the more advanced features of Azure Service Bus. For now, I'm just going to use these values and create my queue. And you can see our queue is created. Let's also create a topic. I'm going to click the plus button here, and then let's call this the order events. I'm going to leave everything else with the default options, and then let's click create. And this is only part of the story. Just defining a topic isn't enough. We also want to have subscriptions. And it's important that you define your subscriptions before you start sending messages, otherwise you might lose out on some of them. This is because a subscription only starts receiving messages from the topic after it's created. So let's say I want to have a notifications subscription on this topic, and the max delivery count is 5, and I'll leave everything else with the default options and click create. So now we have a queue and a topic where we can send our messages, and we can consume our messages from the queue and the topic subscription that we just created. So I'm back in the topic, and if I go into entities and then subscriptions, we can see my one subscription that I have. And if I scroll down, you can see this section here called filters. This is what I meant earlier when I said that we can implement filters on the messages that we send to the queue. So this allows us to define the specific type of message we want to consume for this specific subscription. Service Bus also allows you to define any user-defined properties on your messages, and you can also use these in your filters. So let's go back a level. We now have our one topic with the respective subscription and our one queue. We can finally start sending and consuming messages. So let's go into our .NET application and see how we can implement this. I prepared a small sample application ahead of time with one API endpoint and a Service Bus publisher service. Now this service currently isn't implemented, and our task is going to be to implement this service and successfully publish a message to both a queue and the topic. This is because I want to show you both flows in the same application. Now this is obviously not a best practice, but it's going to be interesting for educational purposes. Now we also have one API endpoint that takes in a create order request. This is just a DTO containing some customer info and the line items the customer wants to purchase. If I go back, we have a couple of steps here defining the order ID, the event, and basically what I want to do is to publish this event using the Service Bus publisher. And we're going to return some dummy response to the API client. Now I also have another application which is going to be my consumer for handling the notifications, and currently there's almost nothing there. I'm orchestrating everything using .NET Aspire, and let's start from the app host. So what I want to do is to define a connection string that I can share between my two applications. So you can do this by saying builder add connection string, and let's call this Azure Service Bus. So once I define this with Aspire, I also need to provide the respective value, but I can reference this from my applications by saying with reference and pass in the connection string resource. Now there are two ways how you can define this value. You can start the application, and in the Aspire dashboard you will be prompted to enter this value, or you can go into manage user secrets and define an environment variable called connection strings, and then the name of the connection string, which is Azure Service Bus. And now I can define the connection string value, which I'm going to copy from the Azure portal. So with my connection string in place, I should be able to reference it from my two applications. So I'll close down the app host, and let's go into the publisher side first. So there's an SDK for working with Azure Service Bus from Microsoft. And if you go into browsing your NuGet packages and type in Service Bus, you will see the Azure Messaging Service Bus library. Let's go ahead and install the latest version. And this contains the abstractions that we need for publishing and also consuming messages. The default abstraction you're going to use is a Service Bus client. So let's define the client instance, and I'm going to configure it as a singleton service. Now, one thing I will need is the actual connection string. So I'll say return new Service Bus client, and let's provide the connection string value. I don't currently have it, but I can define it as a local variable, and I'm going to get this from my configuration and getting the connection string called Azure Service Bus. We define this in our Aspire app host. So now that I have my Service Bus client, I can go into the Service Bus publisher, inject this as a dependency. So let's add the Service Bus client, and I can start using it inside of the publish order created event async. So let's make the actual method async, and let's define a few constants. So we're going to have one constant for our queue name, which is going to be orders. And we also have a constant for the topic name, which is going to be order events. So what do we need to do? Well, we need to define a new instance of a message, and the Service Bus SDK defines an explicit Service Bus message. There is also a Service Bus message batch, which allows you to send multiple messages in a batch. And I'm going to use the constructor here that takes in a string body. So how do we get the message body? Well, we can serialize our order event as JSON. So I'll say JSON serializer from system text JSON, and let's say serialize and pass in the order event. So now we have our message body, and we can pass it to the Service Bus message. Now we can also add a couple of more things on the Service Bus message, like the message ID, and we can define this on the client side. Let's say I want to match this with the order ID. We can define a subject, which is how we can identify this message to Service Bus. And in this case, I have an event type property on the event itself, which I can use. And you also have an option to define some application properties. You can see a suggestion here for defining a customer ID or a total amount. And as I said, this can be useful in filtering on the subscriptions, where we can match on a specific customer ID or a subset of customer IDs and handle those in a particular subscription. Or let's say we want to send a special notification when the total amount is greater than some value. So then we have to publish our message, and I'm going to do two distinct things here: publishing to the queue and then publishing to the topic. Now, as I said, this is purely for educational purposes. You're going to be using one or the other. In any case, you will need to define an actual sender. So I'm going to say await using var queue sender, and you can create a sender instance from the Service Bus client. So you have the create sender method, and you can pass in your queue name. And then actually sending the message is as easy as saying queue sender send message async, and we just pass in the message. As you can imagine, the same thing happens in the topic sender. I can say Service Bus client create sender. The argument here is a queue or topic name, and I'm going to provide the topic name in this case. And then I can say await topic sender send message async and pass in the message instance. So you can see that the SDK is very straightforward when it comes to sending messages. You need a Service Bus client. You use the Service Bus client to create a sender for the specific queue or the specific topic where you want to send your message, and you just send the message. But this is only half of the puzzle. We also need to be able to consume the messages, and I specifically want this to happen from a different application. So I'll go into my online store notifications API, and let's also install the Service Bus SDK. So I'm going to copy the NuGet package and paste it here. And I'm going to steal the definition for the Service Bus client that I had here, and let's drop it into the application here. So we're going to use the Service Bus client to kick off the consumer for our messages. And I'm going to create this using a background service. So let me add a new class in the services folder. I'm going to call it order notification service. And here I want to implement the background service class, which has just one method called execute async. We also want to inject the Service Bus client. Let me add that as a dependency. And we also want to define our queue name and topic name in the order notification service. Now, one addition here is I also want to define a subscription name, which is going to be the notification subscription that I define in the Azure portal. And let's see how we could process messages from our queue. So I'll create a helper method. Let's make it private async task. I'll say consume from queue async. And I'm just going to accept a cancellation token. Let's call this CT. And as you might imagine, if for sending messages we create a sender For processing messages, we create a processor. So I'll say await using var processor, and we want to use the service bus client to create a message processor. Here we can specify a queue name and also some service bus processor options. So let me show you what we can define here. So we have our queue name. What's important to set here is auto-completing messages to false. We want to be able to confirm that we have successfully processed a particular message. This usually involves invoking some business logic, and I'm also going to set max concurrent calls to 1. This just allows you to control concurrency. Now, to make this a bit more interesting, let's also add an iLogger here. I'll say iLogger of order notification service, and let's call this the logger. So now that we have the processor, it exposes a set of callbacks that we can set to handle the incoming message. So we have process message async and process error async. So in case of processing a message, we want to define a callback that's going to take in the incoming message and execute any business logic around it. Now for this, I'm going to create a helper function called process message async, and we're going to pass in the arguments for this callback and also that this is coming from the queue. For the process error async, we're going to do the same thing, except I'm going to define a simple callback called process error async. Now I don't yet have these helper messages, but we're going to define them real quick. Once we have defined our processor, we can start consuming messages by calling start processing async and pass in the cancellation token. Then let's say we await until we get a cancellation, and after this happens, we're going to stop the processing by calling stop processing async. So this is what processing from a queue looks like. Now, as you can imagine, processing from a topic looks almost identical. I'm going to create another method here called consume from topic async, and what changes here is you provide the topic name, but you also provide the subscription name and also the service bus processor options. And we're going to also update this argument to be a topic, and everything else remains the same. And then let me drop in the helper methods for processing the message and processing the error. The arguments here are the process message event args that contains the actual message where we can access the body and deserialize that into the specific event type. Now, obviously, we only have one type of message here. You would have to implement some support for figuring out which type of message you received, deserialize that into the specific type, and then hand it off to a handler. In this case, I'm just simulating some processing by delaying for 100 milliseconds, and then I'm going to mark this message as completed by calling complete message async. If I run into some exception, I'm going to abandon this message. This is going to release the lock that is being held while I'm attempting to process it, and then this message is available for consumption from some other consumer. In the case of an error, I'm just going to take whatever is the exception and the error source and log that using my logger. So nothing too interesting going on here. Nonetheless, we're going to add a breakpoint here and a breakpoint here, and we actually have to start our consumers. So let's say queue task, and we're going to say consume from queue async, and we're going to say topic task and consume from topic async. Of course, this is not the cancellation token, it's called the stopping token in this context. And then I can say await task when all and pass in the queue and the topic task. Of course, I need to also make this method async for this to work. And lastly, I need to register this with my application. So I need to say builder services, add hosted service, and we have to specify the order notification service. So now when the consumer application starts, it's going to kick off our background service and it's going to start listening for messages sent to the queue and the topic. So we have our breakpoints in place in this consumer and this consumer. And let me also add a breakpoint in the process message async method. For good measure, let's also add a breakpoint in our minimal API endpoint. And finally, we can start our application. So we should have three resources here: the API, the online store notifications, which is our consumer app, and then the Azure Service Bus connection string. So you can see all of them are healthy. And I'm going to jump into Postman. And from here, I'm going to send a post request to my API to create some dummy order. Now in the application itself, we've hit the breakpoint for kicking off our two consumers. We're consuming a message from the queue and from the topic. And now once I press continue, I should land on the breakpoint in the minimal API endpoint. Now we're most interested in this part here, the Service Bus Publisher, which I'm going to step into. And you can see I have an instance of the Service Bus client. So we're going to create our Service Bus message, use the Service Bus client to define a queue sender, and then send this to the queue, and also send this to the topic. But you can see that I already ran into a breakpoint on the process message async method, and the source for this message is the queue. So now I'm going to run these in parallel. The consumer already kicked off even before I was able to send this message to the topic, and you'll see we are running these concurrently. So now from the debug context, I can see that the source has switched to topic. So we also managed to kick off the consumer without even completing the minimal API endpoint. So I'm going to press continue, and we should go back to Postman where we can see a 200 OK request. But let me resend this, and I'll remove the breakpoint from the minimal API endpoint. And you can clearly see that we hit the breakpoint here for the queue and then for the topic. And if I go inside, you can see how we extract the message body, which is just our event serialized as JSON. We're going to deserialize that into the actual order event instance, and then we can hand this off to some consumer that's going to take care of this event and execute whatever business logic we need to happen. Once we successfully process this event, we call complete message async, and we pass in the message instance, which is going to mark it as complete in Azure Service Bus and either remove it from the queue or mark it as completed in the respective subscription for the specific topic. So I'm going to press continue, and let's jump into the Azure portal. And on the dashboard for your Service Bus namespace, you should see an uptick for incoming messages into your Service Bus instance. You can see the spike here as we were testing out publishing messages to the queue and the topic. If we go into the queues and then our specific queue, and we scroll down into some metrics, we can see that we are receiving messages in this queue. And if I go back to the topics and then into the order events topic, and we go down to messages, you can see we have messages in the topic itself. So you can see that we have managed to successfully send the same message to both the queue and the topic, and we've implemented asynchronous messaging using Azure Service Bus. Let me know in the comments if you want to see more videos about Azure Service Bus and specifically some more advanced concepts. If you want to learn more about messaging, I think you'll enjoy this video next. Make sure to smash the like button for the YouTube algorithm. Thanks again for watching, and until next time, stay awesome.